Hello, a very good evening, all of our student members and professional members, to the very second day of this training on Excel data analytics. Of course, yesterday we had a robust time with the machine learning engineer from Tech Pet Global Limited, Mr. Destiny Otto. And today we'll be having the concluding part of yesterday's lecture. As usual, the safety brief, please. If you're not speaking, we kindly request that you leave your phone on silent so as not to interfere with the lecturer during the course of today's lecture. We also advise that if you're driving, you park your car in a very safe driving space so that you engage very well and not have an accident. Also, if you are home, which I believe you are home, please don't carry your phone to the kitchen so as not to have a gas explosion. We believe that as we had a safe deliberations and learning yesterday, today we would have yet another safe deliberations. So at this juncture, I'd like to hand over the virtual stage to our trainer for today to kickstart the process. Yes, we know participants are joining. This event is live streamed on YouTube. So people that may join late will have access to the YouTube link so that they can continue with the lecture. For those that may be joining late, thank you so much and enjoy today's lecture. Mr. Destiny Otto, please, the stage is yours.
All right, thank you, Mr. Alpan. Hello, everyone. I hope I'm audible enough. Can you hear me?
We hear you loud and clear, sir.
All right, that's fine. That's good. Okay, so it's a privilege to be here once again. So I'm going to start from where we stopped yesterday, and we'll see how to go as fast as possible, right? Because due to some issues we had yesterday, I couldn't complete what we had for yesterday, right? So I'm going to see how we can go very fast. So remember that when we started talking, we talked about data cleaning. We talked about exploratory data analysis. Then we talked about regression. So I will start with showing us some examples of how data cleaning is done. Then we'll go from there into exploratory data analysis. Now, in showing us how exploratory data analysis how data cleaning is done, I'm not going to use the data I have here that is related to engineering. I'm not going to use the data I have here because practically it's somehow clean. So I'm going to use a data set that I know that is not clean, right? So that just to make sure that you get a real world graphs of how data may show up at times, right? So I'm going to bring in a data set which is having to do with sales and transactions and stuff like that, right? I intend to use it to show us how we could clean data. So we are going to look at it look at various, we're going to look at different perspectives or different areas now of data cleaning. Now, let's start with having to do with some functions in Excel that you will find very useful in cleaning data. So please just write it down. Please just write it down or take note of it as we go on. We'll be bringing them up. So the first function I want to use here is the left function, right? So let's see where we can use the left function just to help us understand the use of it properly, and we'll go deeper from there. So I'll start with trying to create I'll start with trying to recreate this column here called invoice month. Yeah. So on the invoice month column, it's actually derived from or extracted from, this column here, right? And what you want to do, you want to extract just the month. So you have something that looks like a month and a day, right? And if you look at the format, you notice that it's just using a general format. And that's to say that it's not recognized by Excel as a date format. And mostly, if Excel recognizes something as a date format, you will notice that it will rather be falling to the right side of the cell than to the left. It's mostly text that falls to the left, while numbers and dates fall to the right. But then I don't want you to using that as a, as a standalone overall criteria to determine if something, because you could actually change, the position by using different left, right, and justify keys. For example, I could do it this way, right? I could do this. Anybody could do that. So, but ordinarily, if the cell formatting is by default, when you put in a number or a date, it should fall to the right if it's recognized as a date format by Excel, right? So in this case, we want to just extract the month. So I'm going to use, just to show you how the left function works, I'm going to quickly use the left function, right? And sorry, is there something? I'm going to quickly use the left function. And how you use the left function, you specify the cell, which I've done. So I've selected D2. And then the next time I'm going to do the next input or the next variable, the next what we call argument I'm supposed to enter into this function will be the number of characters counting from the left, right? So if I count from the left, all the months there are just written in 3 letters. So I just need 3 letters starting from the leftmost character, and that will give me the month I want, right? So, and then you separate the arguments in Excel. Arguments within a function are separated by comma, right? So this is what we have. So with that, we can extract the month. So we have the month. That's just to demonstrate the use of the left function. What about the right function? If you want to use the right function, very simple tool, as straightforward. All these are tools. All these functions are tools you would use for you would use in your data cleaning process. You should be familiar with them. I call them data cleaning tools, right? So you want, for some reason, you want to extract the purchase order number, and this time around, you want to extract it from this column here, right? So that's called customer PO. So it's a combination of various characters, but you just need this last 6 digits for all of them, and the pattern is same. One of the things you have to understand in cleaning data and handling data, always look out for pattern, because you're automating things, and of course, when you automate things, you just garbage in, garbage out, unless you discover all the patterns you need to discover and make it more dynamic, right? So we'll have, in this case, we want to get the PO number, right? So let me double click this and just find. Now, I'm going to use the right function because I want to take the rightmost 6 characters. So I'm going to come here, highlight it. Now you can just go to the formula bar here. You see that we have number of characters. So I just need 6 and close that. And to give me the last 6 digits. So fortunately, it's the same throughout the data. So it's just going to pick out the last 6 digits, and that's it for the right function. So another function I want to use is the mid function. Now, in using the mid function, there's something you need to take note of, right? So the mid function is slightly different. I'll call this location. All right. In using the mid function is slightly different in terms of, the arguments or the inputs, the variables you need to input to the function. So you need to specify where you want to start. That's the difference. So so in this case, I'm going to be trying to extract the location, but I'm going to be trying to extract it from this column. So if you notice, there are two kinds of location here. There is Sydney, there is Melbourne, and all that. But then we are going to, you probably already begin to notice that they are not the same length, the locations, but let's get there. So I'll select the cell, which is G2 here. So, and then I'm supposed to specify where I want to start. So I'm going to start from 1, 2, 3. There are 3 characters before the Sydney. So I'm going to start from 4. And then for the Sydney, we have 1, 2, 3, 4, 5, 6. So I will need to put the number of characters as 6. So it's going to start from here, and it's going to count to 6 and extract that. And if I press enter, we have Sydney. But then when we decide to say, okay, let's take this down, we'll obviously run into a problem, right? So we have the case where the Melbourne was cut off, right? And we don't want that. URNE was, or RNE was cut off, right? So what do we do? Now, in this case, it might just be Sydney and Melbourne, but let's just imagine in our mind that there is a whole lot of different lengths, maybe just 2 characters, maybe one just has 1 character, some of them has 1 character length, the other ones have 2, the other ones have 3, and all that. So what are we supposed to do? This one, in this case, has 1, 2, 3, about 9 character lengths, right? So we want to make our formula more dynamic, such that it's going to change, or it's going to increase based on whatever it comes across. It's going to expand, right? So it's going to be able to return exactly what we expect as it cuts across different conditions, right? So how do we do that? I think one way we can do that is by leveraging on this 6, because remember, the Sydney is 6 character, and that's why it returns fully. But the Melbourne, so the whole problem is starting from this 6. If you can see it, the whole problem starts from this 6 here, right? Because some of them are 6, some of them are not 6, right? So if there's a way we can make this 6 to be a bit, adaptive, right? So as it goes down the cell, the rows, if there's a way we could make 6 more adaptive, that will solve our problem. So how do we do that? So one way we can do that is by either using what we call the find function, right? I'm going to show you how the find function works. I'm going to show you how the find function works in a second. So this is how this find function works. Now, if we have the find here, and here's the find function, what it does is that it looks for a particular thing within a text and returns the index position, right? That index position will serve as the number of characters you count before you get to it. That's just what the index position means. So in the find function, you want to find something. In this case, you want to find the word hyphen, the character hyphen, and want to find it within this customer PO, right? Okay, let's just use here. And then after that, there is also an optional variable here on which you can specify where you want the count to start, right? Why we use this variable is because we have 2 hyphens. We don't want to start from the beginning, because if we start from the beginning, we are going to just be looking at this hyphen here. It's going to return number 3 because that's the position of this hyphen. But I think what we are interested in is the second hyphen, because you will notice that all through the data is this hyphen separating this from this. So you notice that pattern, right? So want to find out the position. If we can have a way of finding out what the position of that hyphen is, that is going to help us be more adaptive. So I will start from, instead of starting from number 1 or 2 or 3, you know, if you didn't put any variable there, any value there, by default, we start from number 1. I'm going to start from character 4, right? Starting from character 4 is going to return position 10. So what that means is, if you count the character, get to this hyphen, you have position, you have the index position of that hyphen is number 10. Now, if I decide to pull this down, I decide to copy this down to other cells, you'll notice that for this Melbourne, the index position is quite different, right? It's 13 instead of 10. And yes, we have gotten a little, we are beginning to get a little clue or a little hold on how we can handle, you know, the dynamic, how we can make this, our formula, more adaptive, right? So you just quickly notice that this one is different from the other one. And then we have 13 here for Melbourne and 10 for Sydney. Now, going forward, how do we bring this into the formula we wrote initially? Now, remember, we made it such that for Sydney, it will pick up 6 characters, right? And to get 6 characters, okay, let's put in, instead of putting 6, if we put 6, we are hard coding it. So instead of putting 6, let's put our find function, and then we put in the text we are supposed to find, which is the hyphen, right? So we are putting our find function within the mid function, but it's taking the position of that 6. But then it will return 10, right? But we don't want 10, we want 6. So there's something we'll do about that. That's G2, right? Right? And then starts from number 4. Now, the find function returns 10. Now, for us to get 6, we'll minus 4 from 10, and it will give us 6, isn't it? That's correct, right? So when we do that, you see that we have Sydney here. But then when it gets to this place, it will no longer be 10 minus 4, it will be 13 minus 4. And that will give us, instead of giving us 6, it will give us 9. So let's copy this formula down and see what happens. You see that we now have Melbourne complete, because the 9 character is accounted for. Right? Sorry, there is. All right, please, can you guys let me know through the chat room that you are following me, guys? Just let me know through the chat that we are together, guys. Through the chat room, I want to see your messages, guys, that we are together. If you are following the class like you kind of understand the direction we are going, just kindly indicate, with the chat room. Okay. I see Nima Yusuf Zango says yes. Daniel gives a thumbs up. Someone asks, Alabi asks if there will be a recording of this. So, moderator, is there a recording? Will there be a recording? Okay, Manuel says yes. Yes, sir. Moderator, will there be a recording? Is there a recording of the session? Okay, someone's mic seems to be inadvertently left on. All right. So I don't know if the moderator is still with us, but moderator, please. Okay, so I don't know if there's a recording, but I'm sure there should be. I don't know if it's currently recording. Okay, I don't think it's recording, but I think it's the moderator's place to do something about that.
Hello, sir.
Yeah, I can hear you.
It's recorded on YouTube.
Oh, okay, it's recorded. Okay, that's fine.
Yeah, both
All right.
today's lecture and yesterday's on the see on YouTube live.
Oh, all right. Thank you. So let's move on, please. We are done with, we have handled typically three kinds of function that you would likely come across while you are doing or working on cleaning data, right? We have come across, we have handled three different functions, but there are other ones apart from the ones we already touched. There are other ones you would want to know about. So the next thing is, let's assume that for some reason you want to extract, you want to extract, you want to what we call concatenate, like join two things together. Now, I want to say this. Why Excel might have formulas like split column or split text or from text to column, I want to say this, that using formulas is more dynamic and based on my experience. And yeah, it is more dynamic because those split columns, have a fixed way of just splitting the columns into any number of, splitting the text into any number of columns you want. But the problem is they are not, by the time you see a lot of changes, they are not that adaptive to the data as you go down the rows, right? So they just have a way of you have to have either a fixed number of character or a fixed, for example, you have to have something like a delimiter, like this hyphen. You have to have something like that, or else it will almost be near impossible, right? Or if you're using the number of character. But then when you write formulas, you make the whole thing far more dynamic, right? And more adaptive, and yeah, you can do more. You eventually end up getting something that is more accurate. So the next thing you might see is the case of where you might need to concatenate two data. It's very simple. You just use the AND function, the ampersand, right? You just use that to concatenate them. Let me show you how. So in this case, I want to concatenate these three columns, 1, 2, 3, to form a something like an account number or a bank detail, or just call it a bank detail or bank details, having all this information, right? So how you do that is just simply, all right? It's just simply to use the ampersand, right? So we have this cell and then use the ampersand. Now, I want to put a hyphen within them. So I'm going to put, because I'm writing text here now. So that's why I'm putting this quotation marks open and close when you want to add text, right? So, and then I'll put in the ampersand again, and I'll put in this one. I'll put it again. This time I want to add the next hyphen, right? And then I'll put it one more time, and then I'll have this, and I'll press enter. And that will automatically concatenate these cells, these columns. And so generally we have things like this. Now there is also the concatenate function. If you want to use that, you can use the function called concatenate. But why I don't want to use it is that somehow it's getting what we call deprecated, right? So, but you can use it. It's pretty straightforward too. All you just need to do is enter the first text, enter the second text, which is similar to, just entering the first. So you're going to have, you're going to have something similar to this. So I don't want to do that again. Now, let's start doing something more serious, right? And it's going to be with this one and these two columns. So because of, I just want to ensure that I have, a little bit flexibility. I'm going to move these two columns Someone is saying there is no audio. Please, others, is it the same on your end? So let's move this. Okay. All right. Daniel says he can hear. All right. Let's move these two columns here. I'll move this column to the edge so that it's going to be a bit easy for me to work with. All right. I'll also move this other one, or better still, I just copy them. Just copy both of them. Sorry. Right, let's bring them to the edge here, just so that I could work with both. All right. The next part of data cleaning we are going to deal with has to do with what we call trim and clean, and also substitute, right? So sometimes you may have, you may discover that you need to have, you have something like this, what we call unprintable characters, right? Unprintable characters. So in a case where, hello? Guys, am I audible? Can I be heard?
Yes, your head, sir.
All right, thank you. So sometimes you might have a case where you have what we call unprintable characters, or you have a case where you have a number, but some characters are attached to it. So you can't use this for calculation. If you attempt to use this, you have something like this, and then you have times 3. You're going to have value error, right? What do you do about it? See what you do about it here. You need to extract or pick up what you need, yeah, from this text, because you can't convert it to numbers. If you think it's just about the format, you decide to, say, okay, it's just about the format. You go and change the format here. It's not going to change anything. It's still going to throw up an error. Yeah, it's showing number here, but it's more like it's forced to be a number, but yet it's not a number. So even if you try, even after changing the format to make it into a number, you still have that error while trying to use it for calculation. So what we want to do is to pick up, is to clean this data, right? What do we do if we want to clean this data? Now I want to show you guys something. I'm going to do something very briefly. Let's remove this S. Let's extract all the characters apart from the S. So in this case, I'll use the mid function, right? Or which function do I use? Okay, I just want to extract the S. Okay, let's do this for the first row alone, right? So in that case, I'll use just the right function. So I want to show you guys something quickly. Then this is 1, 2, 3, 4, 5, 6, 7. So I'm going to say 7. Good. Now I've extracted from the last character to this character that appears like a space between the S and the 7, right? You'll notice that that character appears to be there, right? Now I'm going to write this same number, but I'm going to write it manually by myself, 742.50. Now, apart from the fact that you have noticed that this and this, that this and this are kind of different. This is falling to this side. Now, there's something I want to show you guys now. Look at this carefully. There's what we call a Unicode, right? What you use it to do is that you use it to return the code that Excel uses to recognize all kind of character, but it only recognizes the first character of every word or every content of the cell, only the first character. So I'm going to use Unicode on this cell now and press enter, and you see 160, right? Now let's use Unicode here too. I'll show you what that Unicode is in a moment. And you see 55. Now, what this character does, what that function does is that it returns only the first character of this, right? It returns only the first character, that's 7 in this case. And this one, it just shows that they are not the same thing, right? Whatever it is that is there, they are not the same thing. They are not the same thing, okay? So, and remember in Excel, if you attempt to put a normal space bar like this, and then you press enter, it's not going to stay. Excel automatically removes any space bar you put before a number or at the start of a number. So if you attempt to put a space bar, so this is definitely not a space bar, but then you can't see it. Now, if I go to what we call ASCII table, if you look on my tab, we have what we call ASCII table. I'll go there. Yeah, it's a standard table for both printable and unprintable characters. This shows the codes of all characters. I just hope you guys can see my screen properly. Now, if we trace those codes we saw there, in this case, for the first case, we saw 160. For the second one, we saw 55. If we trace their numbers through here, right? Sorry. Okay, good. If we trace their numbers through here, that's okay. 55. You'll notice that we have 55, we have the character as 7, right? So that is telling you that the one that says 7 is 50, the first character is 7, is 55. That's correct, that's the code. But then remember, the second character is 160, right? So let's go and see what that 160 is. So this stopped at 64. So let's check. This stopped at 127. And let's check down here. 160. You can see the name called non-breaking space. Non-breaking space is a character. Now, if you look here, description, character, from 128 all the way down to 160, you can't see anything written here. These are what we call unprintable characters. You can't, they are not printable, so they can come out in many forms and many ways, right? You are not going to see them, but there are some of the things that affect data analytics, right? They are non-printable characters. You see that they are not so visible in Excel here. So they could come up from any, it could come up as a result of anything, from the source or whatever it is, particularly from, sensors and measurement devices. They could just come up from there. So there are many other characters you can see here, see other characters here, and stuff like this. So all of them have their codes that Excel recognizes. Now, what that shows is that whatever this thing is, it's not ordinary space. Yeah, it's one of those unprintable character called non-breaking space. Somebody say, okay, what will be the code for space, your normal space bar? The code for space bar is 32, right? You can see it here, 32. That's the normal space you use, right? So let's go back. So we have a character that we don't know, we cannot represent, we don't even know where to type it on the keyboard. So what are we going to do about this in this case? So what we are going to do is I'm going to use a mechanism to substitute that character, because you can't delete it. You don't know how to get rid of it, right? But one thing you can do is that you can use the substitute function, and then you say whatever that thing is, you don't care, but you want it to be substituted. And then if you are using the substitute function, you would also need to use, you'll also need to find a way to index it, as to put it as represent it as an index number, right? You need to be able to represent it as an index number. So that is basically what I'm going to be doing in a moment. All right, so let's go about this. So the first thing we want to do is we use the substitute function. And how does the substitute function work? Let me use something else to show us how the substitute function works. If I have Sydney and I want to substitute maybe the n here, and I want to change it to a comma, all I just need to do, the first variable says I should select this, and then I put in what is the old text I want to substitute is n. So I'm going to write n. Okay, sorry, put n. Then I'm going to substitute with a let's say comma. So that character n will be changed to a comma. So you can see what we have here, right? Seed, comma, UI. That's how the substitute function works. Or let's say I want to remove it, replace it with nothing. I'll just this opening and closing quotation mark with nothing between shows nothing. So I've removed it, I've substituted it with nothing, right? So I could also do this for this, right? But then you'll probably be concerned to ask, how will I get the character to write it down? And that's very simple because we already talked about the left and the right function, right? So that means that if I want to substitute whatever it is that is here, all I just need is, okay, first I'll select this, and then I'll use the left function. I'll use the left function to point out exactly what I want to substitute, right? I'll put this comma. Now, what I want to substitute are the first two characters. Whatever the second character is, I don't care. The first one is an S, or whatever the second one is, I don't care. But two of them, S and that space bar, I'm substituting them. I'm substituting them and replacing them with nothing. So I'll put an open and close a quotation mark showing nothing. I'll press enter. And then you see, now you quickly notice that we have, you easily notice that we now have substitute. Now let's do this. Let's use that Unicode again to check the code of the letter that is there. And you notice that we have 55. So here we now have, instead of a space bar, instead of something like an unprintable character, there's no other thing, because 55 stands for 7, right? So I hope that is clear enough, guys. Is there any question before I write the formula, before we copy the formula down and move to the next? Are there questions, guys? If you have a question, kindly indicate so that. Okay, so let's move on. So I'm going to copy this formula down here. So I've actually been able to, make this into a, numbers. Now, they are not yet in number form, but the way it is now, you can actually just change the format to a numbers format. Wait a minute, it's not working. Let's see why this did not work. Okay, it works then. So it's now currently, you'll notice that I could now use it to, for any calculation I want, and it's going to work the way a number should. Now, someone would ask, of course, you have the currency, format here. So if you actually wanted to do a currency, it's not to add S, you wanted to use a currency format, it's not for you to add X. You can just change it to a currency format using this drop down here. So that is it for this, right? Now let's go to the invoice. Let's go to this this other column, the invoice and credit. Now the invoice, this column has a number of issues. The first you notice easily is this character, this strange character here. And the second you would notice is that going along the line, you notice that there is something like a space. It might be an unprintable character. It might be a space, who knows? But let's see the kind of character it is. Say using the Unicode function, select this. So it's showing 32. And from our ASCII table, remember we said 32 was the normal space bar. So it's a normal space bar. is different from the previous one we saw before, right? Now, we now know that this is a space bar. Now, maybe if you scroll down, you'll probably see more of this. But we want to use a function to take care of that, right? If you look at it, it's not going to look so easy to use this substitute, because one of the things here is that other texts here are having different lengths. They don't have it, right? And if you don't see if in using substitute, the substitute function does not see what you want to substitute in any of the rows, it's going to throw up an error. So that's why we can't use the substitute function here. But what we can do, we can also use the left function. Remember, it's not all of them that has this spacebar. What we can do is what we call the use of the, to me, this is what I call proper data cleaning. This is of the trim and the clean function. What we call the trim function, right? The trim. So what does the trim function does? Wherever there are spaces or spacebar before the data, or after the data, or after whatever is written there in the cell, maybe before or after, and sometimes even in between. Like if there's a lot of spaces between, like two spaces in place of one space, the trim function will take care of it, right? So let's see how the trim function can help us here. So I'll do this. This one has no problem, but let's see the one that is our attention, our focus. And this is the invoice function. So you notice that it has been taken care of, right? But then we still have this questionable, question mark here, right? I think one of the ways to handle that is to use what we call the clean function. Clean function. This is different from the trim. So the clean function, what it does is that everything non-printable characters from a text, it actually cleans it out. So I'm going to wrap this trim function inside the clean function, so that what the trim has already, when the trim is done working on it, it passes it over to the clean function, and then any non-printable characters found there will be removed. So you notice that that particular character is no longer there. And then when I pass it down, all those question mark has vanished, right? Now, one other thing I would have said, well, this is nice, this looks very good, but I'm still not comfortable because, maybe because I'm a perfectionist or something. I noticed that, they are not looking properly. They are not looking so good, properly aligned. I mean, in the sense that some of them are uppercase, others are lowercase. So in this particular case, I want to put all of them. I want to make all of them uppercase. So I'll use the upper function. I'll wrap that, and all this basically is what I need. So every one of them will be in the uppercase. Now, all this basically is what I need to clean, and some of the things I need to clean data, right? So there are some other things when we talk about cleaning data. Now let's talk about some other things apart from the ones we have done. Now we talked about handling duplicates in data, and we also talked about handling null values, right? Null values. So how do we go about duplicates and null values? So good enough, Excel already makes that very easy for us, right? So all you just need to do is to highlight the column that has a duplicate, right? I don't know if any of this column actually has a duplicate, but if now you need to be careful in handling things like this, right? You don't just pull out everything duplicates, right? No, you have to ensure that it's a duplicate indeed. So sometimes for you to ensure that it's a duplicate, you need to select 2 or 3 columns, right? 2 or 3 relevant columns, because some things they are like, for example, now you look at this column payment number, you have 1 repeating, you won't say it's a duplicate, right? This is not a duplicate, right? So you might need to highlight maybe even more, so many other columns to confirm that that is a duplicate, or you might just need to highlight the whole table, right? It might be more than 1 column, it might be the whole table, and then you actually use the function to delete or remove duplicates, right? And how do you do that? If you go to data and sorry, let's remove this zoom tray from here. Okay, good. If you go to the data tab, under the data tab, you have what we call, if you look here, you have what we call this, you have this function called remove duplicates. So removing duplicates from the sheet will remove duplicate rows. Now let's confirm, right now the sheet has the count of the rows here, the sheet has 935 rows, right? Sorry. Actually, the sheet has 85 rows, not 900. That is a combination of, that's the sum of all the rows. Now, the sheet has 85 rows, right? Now, let's highlight all the sheets and see if, I don't think there's any duplicates in this particular, but this is how you remove the duplicates. So let's delete this. And then we have this dialog open here, and it's asking, do you intend to use all the columns for duplicates, all of them? And you don't have to use all, right? You just have to make sure that you know what you want to do, right? You know what you want to achieve. You know what your data type. You know what's the content of your data, so you can tell when or where there will be duplicates, right? So let's just leave all the columns selected, and then we'll click OK. So look at the response here. No duplicates found. So if there was a duplicate, it would have been wiped off, right? Now that's it for handling duplicates, right? Then handling null values. So some of the ways you want to handle null values is to delete the rows or to replace them. Let me show you what I mean. Let's say within this paid amount column, let me use this one we just worked on. Where is it? Okay, good. Within this column, we happen to have maybe a few empty cells. Now, why you could use a function to, why it is possible for you to use a function called isBlank, right? To tell if there is this thing. I don't see this making a lot of sense in terms of I don't see that making a lot of sense because of when we talk about big and huge data, right? So there are several ways to do this. There's more than one way, but a simple way to do this is to use what we call the go-to special. Yeah, so you could either do it this way, right? Where you have to find columns that are missing and replace them. So under the find and select, you see what we have what we call go to special, right? So when this dialog is opened, you can go to blanks, right? It's usually advisable you highlight the column first, but I didn't highlight it, right? So you can go to blanks and click OK. So let me highlight the column first, okay? Now you will notice something, that those cells have been highlighted. And when you scroll down, if it happens that there are any other empty cells there, you will notice, you will also find out that only those blanks have been highlighted. No matter how many there are, they will all be highlighted. Then you can then use the replace function, here to replace them. Let me say replace them with 0, for example. Yeah, replace them with 0. I'll click replace all. So say all done, we've made 4 replacements. So you notice that these thing here have been replaced with zeros, right? That's how you handle null values, right? Sometimes there might actually be values written as NaN, or null, anyhow you see it. All you just need to do is to use the replace function to replace null. You write the letter here with whatever it is you want to replace. And then another way to handle it is to use what we call the, I think we'll switch over to the other data set now. To use what we call filters, right? So let's insert filters here. So you click on filters and your data set now has these arrows you can see here. And so if I click this drop down, you will notice that there is a list of every unique numbers here. And with this, you can easily find, and once you untick this, it's going to be filtered off your data. You will not see anything null. For example, if I untick this now, click OK, notice that null has been removed. Now, let me say I delete this and left it blank, right? Now, when I click this, you notice that there's what we call blank here, blank. So I could unselect it and click OK, and it will disappear, right? So that is another way to handle them, right? If I could bring them back, and you see them, they are back here. So this is another way. It's not just that it's going to disappear. This whole row would have to disappear, right? This whole row, the whole rows where you have the. So those are some of the ways you can handle this thing. So now enough of data cleaning, because this part is actually so boring, right? So let's go into where there's action, right? So are there questions, guys? Are there comments before we go on? Are you guys following? Hello, guys. Are you guys following? I'm still waiting. I want to know that we are together, guys. Moderator, are you there? Can I be heard?
Go ahead, sir. I'm hearing you.
All right, brilliant. All right. Now, I have different kinds of two different kinds of data here. And one of them is what we call the Evolve data set. It's an open source data set available online for free under open license. So the other one is another data set from one of the companies around. Now, what we want to achieve here, we're going to first of all, do exploratory data analysis, and also we are going to build a regression model, right? So before that, let me show you the second data set I have. All right, good. All right, great. So this is the second data set I have. Okay, I think I showed us this one. So this particular data set have over 110,000 rows, and the Evolve data has over 15,000 rows. Now, okay, I don't know where to start. I don't know where we'll start because it's kind of interesting. So many places. All right, let's start from somewhere. All right. So talking about exploratory data analysis, you are given a data set like this we want to start exploring to know, to know where, to get some insights and information from it, and probably to know where to go to get answers to some questions, right? So whenever you get data set like this, one of the first things you want to do is to get a little insight on, the nature of the data. And I usually recommend whenever I get data set, try to put it in, make it into a form of tables, right? Because of the added properties or additional properties of tables, right? So I'm going to first make it into a table, or even if you're not going to make it into a table, you try inserting filters. Okay, instead of tables, let's see if we can insert filters by coming here and clicking on filters, right? So from here, I would already begin to get an idea of the kind of data here. Now, what kind of ideas, what kind of thing am I getting? Number one, the format of the data. This data shows that appears to be a date. But when I click this drop down, you will notice that there's what we call text filters. This already shows you that Excel sees this as a text, not as a date. So if it's a date, what you will see here will be date filter. You see what we call a date filter. So for you to see text filter and you see A to Z, sort it, all these are text functions or functionalities associated with text, right? So for you to see text filter shows that this is not recognized as a text, as a date, it's recognized as a text. And if you're going to work with with this data as a date, you need to convert it to a date format, right? You need to work on it to do something about it. Now, the next thing I want to do is I'll click here. This one is a text, right? And it's okay because it shows the name of the field. But other things I will see is that I can see other fields here. I can see that we have 1, 2, 3, 4, 5, 6, 7. So we have 7 different fields, right? And if I wanted to see, you are seeing a 0, but if you go, by the time you start going down, you see other fields. But if I wanted to see only DARA fields, that's DARA, I'll highlight only DARA and I'll click OK. And all you will see here are only the DARA fields. If you scroll down to the end, the other rows will be hidden, and all you will see will be only DARA. Now, that is it for filters. Highlight all again. And then for the reservoir, you can see that we have a number of, this thing for reservoirs, and we probably have blanks. I don't know, it doesn't tell how many there are, but you can see clearly that there are blanks there, at least one blank or more, right? Then the same thing with the well name, you check the well name, and there are some of them that happen to be blanks as well, right? You check the oil rates. First of all, you will notice that the name of the filter here has changed. And when you see sort, it's not from A to Z, it's from smallest to largest. So Excel actually recognizes this as a number, right? So these filters give you a lot of information. So filters are automatically created when you insert a table, right? So that's another thing. Now, the same thing with this, and I guess it's going to be the same for all of the rest of them. Yeah, so they are all recognized as numbers, which is good. Now, let's do something about these dates, right? One of the first things you might want to do, or you might be tempted to do, which is not really tempted. The first instinct you have, okay, let's try converting this to a date format. Maybe because it was in general format, then you try change it to maybe the short date. And okay, let's make the whole column, right? Let's highlight the whole column. You highlight the whole column by pressing Shift, Control Shift and downward arrow. And so you click on, you select short date. Now, but if you come here and click this, it's still recognized as a text. So that you just change the format here doesn't matter. So sometimes you might not know exactly what to do here, right? But one thing you can do, you can try using some of those functions you have learned. For example, let's insert a column here. You can try, for example, using the trim function and seeing what will happen, right? The trim function doesn't appear to do anything. So you can try a number of things, right? So, but one of the things you just go straight to doing, or for me, I will just do, because sometimes the data is a whole lot and there's a whole lot of stuff that within, in the midst of the data, I might not want to bother about knowing them, but I know that the data has this good format because I can see it already here from the from the drop-down filter, right? So one of the things I might want to do is I'll use a date function to create a different cell, different value from this cell, this column, a different column that will be a date column. And how do I do that? I'll use the date function. Now, I'll have to pick, it says I'll have to, the date function takes in year, month, and day as text, right? So I'll have to find a way to extract the values here and put them in here according to this format. And in this case, we have already learned something like like the left, right, and mid functions. So for the year, I'm going to use the right function because the year is rightmost here. I'm going to use the right function, and I'm going to extract this. There are 4 characters there, and that will serve for the year. Then for the month, I'll use the mid function, the mid, and I'm going to select this text. Then I'm going to, the stats will be the 4th character, 1, 2, 3, 4, right? And then the number of characters will just be 2. Then finally, I will use the left function. The left function will take only the first 2 characters, right? Which is, 31, as you see in this case, right? So, and then I'll put in, okay, I think I missed a parenthesis. This is what is cost. So you notice that the date has been formed, and see how it falls to the right side of the column. So let's try copy this formula down to all by double clicking here. And let's click on this drop down. Now you will notice something here that is no longer text filters, is now date filters. That's to show that Excel now recognizes this as a date, right? And then you can see all these things here. The same thing with the sort here. The sorting is now oldest to newest, newest to oldest. That's to show that Excel now recognizes it by date. Now, just in case you want to see the data in a format that you want to, let's say you are asked to show, the newest data. You should sort the data from newest, so from newest to oldest. This is a very easy part to do that. So I'm just going to rearrange it. So it's going to start from the latest date. And now you will notice something that this particular this thing shows errors here, right? And I think if you look very well, you can tell the reason for that, right? You can tell the reason for the error. The reason for the error was simply because, the formula we wrote, somehow, somehow this column happened to be, not to be the same length as the original values we saw, right? So you discover that it has some cases where the data doesn't align with, so you see we're having something like 9993. That's because the formula we wrote is actually picking up. So for example, if it's the mid function now, it's taking up only this. So there's something we can do about the mid function to make it more adaptive. So let's go back to how it was before. Okay, let's leave it like this. Okay, no, let's go back to how it was before, and we'll write it back again. So don't get worried about how whatever is happening here, right? So let's write this. Let's make this formula a little bit more adaptive, right? So in making it more adaptive, the only thing you need to take note of is this what the delimiters in forms of strokes, the slash you see here, right? So just like we did in the other cell, all we need to do here for the year would likely have no problem because anyhow it is written, it's always 4 from this side. Oh, hold on a minute, guys. Now, before I move on, I think there's a problem here. Let's change this to, instead of having a date format, let's change it to a general format, okay? I think that would kind of that'll kind of help us. Now let's look at it again. Okay, so actually some of these values here were real actual dates, right? It's just some of them that were actually text, right? So in this particular case, these numbers you see here are in Excel what represents or what is used to represent dates, right? So if you want the dates to show, you have to write them in the format. You have to put them in that date format, right? So let's do this quickly. Let's take it back, right? All right, so we have these dates here. Let's see how to tackle this. I don't know why is this one not going? How is this not changed to the date format? Sorry, guys, a second. All right. I think this data somehow is going to give a little trouble. So I'm going to leave this data set for now. I just don't want us to waste time. I'm going to use the other one, right? So this wasn't the one I even planned to use. So, but I just wanted to. So this particular one, it's actually going to give us some more issues, which I did not anticipate before now. So I'm going to leave this particular data set, and we're going to use. Actually, that's the one we're actually going to use for most part of the class, which is the Evolve data set. So I'm going to use the Evolve data set. Now, in using the Evolve data set, we are not going to use the whole data set, as that would be kind of would be too much. So we are going to select or collect some of the data, and we are going to use them. So the first thing we want to do here is let's take the data for only one well. Now, don't get me wrong, we are still going to come back to that data set. But for what I wanted to demonstrate, I'm not going to use, for the particular thing I wanted to demonstrate, I'm not going to use this because the data is more messed up than I actually imagined at first. So I'm not going to use that particular one. So I'll come back to that data. The other things we'll use it for because it's important we do. I'll come back to that. Now, let me quickly use this for the demo. The particular thing I initially wanted to use that one for, right? So, so what I'm going to do is that we are going to take up only data for only one of the wells from here, right? And I'll use that to demonstrate what I wanted to demonstrate. Now, I'm going to just like select this. Control C. Okay. And then I'll Control C, copy everything, right? And let me just delete everything here. Okay. And I'll paste it here, Control V. Sorry. Control C, Control V. All right. I don't like the way it's looking. One of the ways you can adjust your cells instead of adjusting maybe the columns or the rows individually is to highlight everything, right? And when you've highlighted everything, you just go here, try to adjust only one of them, the rest will adjust accordingly. Let me do this again. Yeah, the rest will adjust, right? Good. Same thing with the rows. If I want the rows to be adjusted a bit, okay, I'll just highlight this, highlight the rows. They'll all be adjusted, but you must make sure you highlight it here, okay? So this is what we have. So we have some missing values here and there, and we have some other parameters here. Now, but our focus will be on exploring, trying to explore, you know, and get up some insights from this data. This is the data for only one well. So let's see what we can do. Now, the good thing about the good news in exploratory data analysis is that it's now automated, right? So before now, when we want to do exploratory data analysis in Excel, we would have to, you know, plot a lot of charts here and there. You know, for example, this is a line chart. Okay, I didn't know that anything was highlighted. Okay. Let's do this again. Okay, so for example, this is a line chart. All right, this is a line chart, and why is this highlighted? All right, and let's put in the figures or the data. Just go to select data. Add. Here you can put in, let's say we want to make a plot of the oil production and the gas production on the same plot. So I'll call this the oil, and the X will be the dates. So I'll highlight all the dates column. Then the Y would be the oil production column, which is this one here, the oil rates. Right? And I'll highlight everything. All right. I'll click OK. And I will have to add another series for the gas. I'll call this the gas. And for the S column, it's going to be the dates. Then for the Y column, it's going to be the gas. And I'll click on OK. Sorry, sometimes this thing just kind of misbehaves. Let's write in the values again for the Y columns. Same thing with the gas. Still having the same problem. Okay, let's do it this way. Oil rates. Good. Let's do it this way. Gas rates. Click OK. So we have a plot of the oil and gas rate. So it looks so nasty, but don't worry about that. I'm just trying to show us what you would have to go through if you are exploring data. Okay, because they are in different, let's put them in different, let's put a secondary axis to these plots. Let's change chart type. We'll do a combo. And it's just going to be, no, it's still going to be a line. But we would have to make, sorry, what have I done? Okay, let's not go now. This is just an example of some of the things we'd have to do. Now, before I go on, there's got to be you need to understand that there's a difference between exploratory visualization and explanatory visualization. So, explanatory visualization is more like you creating a chart you would use to show a particular information or demonstrate, or you are done with all your data exploration, you are done with all your data analytics, but you want to create a report to show results of your findings. Yeah, but in exploratory visualization, you are using it to find. So the purpose of you using the charts, doing the chart is actually to check, to check for information. So you are trying to find an information, right? Now, they are not, there could be the same type of charts, but what the difference would lie in how they are, the purpose to which they are created, and also how you create them, right? So whereas for one of them, your focus will be on trying to work on the design and all that, but for the other one, your focus is on trying to just find out any information that is useful, right? So, so for the explanatory, we have already found out what you want to find. Now, in this particular case, we are talking about exploratory, right? So don't get anything mixed up. So we are going to extensively treat this as we go on. But I just want to show us an example of how you would normally make a plot, maybe before or ordinarily when you were exploring, right? But it doesn't have to be so again, right? It doesn't have to be so. If I want to, before I go on, if I want to, let me remove this. If I want to, sorry, if I want to explore data now, it's a little bit different, right? Because I have more tools and more features in Excel to explore the data. So one of such very important features is the use of the analyze data function that is now available in Excel. So basically it uses artificial intelligence to try to give you insights. It's going to plot multiple plots and you would find anyone. You try to browse through them, or probably you can even do what we call a search, right, for the particular plot. Now, let me show you what that means. I'll go to home and you'll find the analyze data function here. Now, I'm not so sure for versions of 2016 and all that, but if you use a licensed Microsoft 365 version, you are going to, or Office, I think Office 365 as well, you're going to find this button here, right? So what is going to happen is when you click on it, you are going to have this panel here, or this pane by the left, and it's going to show you a number of possible ways of combining data, right? Both whether it's line plot or bar plot. So you can scroll through them, or then you can ask directly the specific things you want to find. See examples of the suggestions. So you can say how many different well type are there, percentage distribution of well type, top one well type by total gas rates, right? So let's first of all scroll through some of the insights that are here. So in this particular case, now before we go on, I feel I should first of all we should first of all talk about, let me delete this chart. We should first of all talk about these headings. What are these column names you see here? I'll probably give them a proper column names. This wellbore code you see here is more like the well, I don't think it's useful because we don't need it. It's just a code that they use there, right? So we're not going to use it in this analysis. Then we have wellbore ID. That this should show the well name for that particular well, or the well ID. And then this is the field name. This is what we call the on-stream hours. Occasionally they shut down the wells for several reasons. So, it's not 24 hours the time the well is on stream. Every well is on stream, right? So they will have to put in the number of hours, recorded the number of hours the well was on stream. Most times, most wells are just on stream for 24 hours for most of the time, but there are times when occasionally around somewhere within the day or the night, they shut down the well, right? So we have this parameter here. So we are not going to use this parameter here. So I'm not going to talk about it, right? Okay, sorry. That's not. No, we are going to use that part. That's not this parameter here. Sorry, this should be average downhole pressure, and then this should be average downhole temperature. Then this is average annular pressure. This is the average choke size. This is also average choke size. Now there is no data here, so I'll just delete. Okay, I will leave this here because I want this to show us something. So we have average wellhead pressure, average wellhead temperature, choke size again. Then we have oil rate, gas rate, water injection. Then we have what we call, now this column is appears to be zero, all through, but it is not. Now let's insert a filter here in all of them rather. So okay, I think it's I don't know. I think it's okay. Okay, this particular well has no water injection, I think, but if you go to the original database, you will see data for some of the other wells. I think maybe this well doesn't have any water injection, right? Okay, so this is the flow kind for it could be injection or production for that particular well, but I think this well is entirely production, so the flow type is just going to be production throughout. This well type also shows the kind of well. Initially, it was drilled to be, it was used as water injection. If at every date you have, you have the well type, a well could be converted from well injection to oil production, or from oil production to well injection, so to water injection. So in this case, I think it's mostly just oil production. Okay, but there's still maybe water injection here, right? So, but I think from the original data, when you explore it, you see other wells that are there. I think about 7 wells total. Now, let's now see how we can, having understood all these columns, let's now see how we can, do exploration here. So I'm going to click on this analyze data. Now you would have to be, okay, so all right. So let's start with the first one. First thing we see here is a plot of the average downhole pressure by the well type. Now, if this information means anything to you, if you remember, exploring is just doing a whole lot of things, trying to see if anything makes sense. If this information means anything to the question you are asked or you're trying to solve, then you can look at it. So, but I don't think this will be useful, so useful. It's just showing, a plot of the oil production, the well type by. Now, in the next one, we have an insight that says water rate. Now, it's mentioning water rate because that's the name of the column here, water rate. Now, water rate shows a repeating pattern, and that's typical of production data over time. It's a time series data, so it keeps going up and down. So that's a repeating pattern, and that's how production usually finds production. Because of that, not just water, oil production too will be like that. So this is pretty just normal. You might not need it unless you don't know. And the data you're analyzing, sometimes it might not be something a parameter you are so familiar with, but then you can get this as an insight and say, okay, that this is likely to be something that changes by time. So it's mostly influenced by time, just as time goes on, keeps changing. Right. So well type oil production accounts for majority of water rates is a pie chart. Then this one says the average downhole pressure and the average downhole temperature appear to form a cluster with two outliers. What does this mean? So when two parameters form a cluster, it's just trying to show that, there are times when there were some outrageous values or outliers per se, because forming clusters just simply means that they have been operating within a particular range, which appears to be normal, right? They have been going hand in hand within a particular range, and all of a sudden you have outliers. So that's one of the things. Now, when they begin to form clusters, two parameters begin to form clusters, what that thing is, what it might be telling you in your data, let's say it's not just one cluster, but two clusters. In a case where you have two clusters, what that could just be telling you could be that you have two processes. You have two kind of relationship, two different kind of, those two parameters have two different kind of relationship, or two main factors that act differently, right? So you can go deep down to, to look at what that could mean when they have, when the pressure and temperature have two kinds of relationship. Maybe at a certain pressure, the behavior of maybe the fluid would completely change, or at a certain temperature, the behavior of the fluid would come. So they would have like two circumstances, or two, let me just call it two environments, or two characteristics that I know you're an engineering student, so at times you see when they try to specify conditions. Okay, as long as this condition is less than this, it behaves this way. As long as this condition is lower than this, it behaves this way. So something like that, right? So that is the idea of clustering there. Then we have this one, when you have average wellhead temperature and gas rate appear highly correlated. So you can easily understand what happens there. It's pretty expected. When you have higher, when you begin to have a higher gas rate, normally you would have your wellhead temperature, you have a higher wellhead temperature, right? So, and vice versa, right? So that is it for that. Then the on-stream pattern, the on-stream hours, that's what we have there. Then we have something like the choke size and the wellhead temperature appears highly correlated. So that means, and it's a positive correlation. So if, for example, I want to use this chart for anything, right? There's a correlation between them. If I want to use this chart for anything, all I just need to do is click on the SAT chart. And here, I'll have the chart here. Oh, sorry. I'll have the chart here on my Excel sheet, right? So that is it for that. So when you have average choke size and wellhead temperature appear, so there's a correlation between them. There's a positive relationship, right? And then we have this case where you have downhole pressure and gas rate appear to form, cluster with two outliers. Again, if it's useful to whatever it is, whatever you want to find, or whatever question you want to answer, you can actually. But then the outliers here will mostly be as a result of zero values of one of the parameters. So the clusters here is fine, but when it's just trying to show that these guys are going. So what you can do is to remove this cluster, and this cluster is just at zero for both of them, for both parameters. So it could be when the well is not producing. I doubt, because average downhole pressure will not be zero. I don't know when it will not be zero, but it could be zero for gas rates. That is when gas is not when there's no production. So this could even likely be errors, right? So again, it's not exactly important, because this kind of errors are outliers. We can take care of them. We can remove them. Then we have this one that says the average downhole temperature and the average wellhead temperature appears highly correlated. Now, with two outliers. So it seems to be highly correlated, but then it has two outliers. So you might want to, if you insert this chart and you want to see what specifically, which points specifically are those points, you can just hover over it and you'll see the points. And what I'm seeing here are zeros for both of them. So either when the measurement was not recorded, or it's usually because maybe there was no value written there, and then zeros was just maybe empty values, cells were replaced with zeros. So you can just have 0, 0 there. So the wellhead temperature, the average downhole temperature, both of them were zeros, because there was no zeros there. So you can eliminate this from the data, get this point and eliminate zeros, points where you have zeros. As there are 2 points where you have zeros, or several points where you have zeros, can remove that. Then average downhole temperature and oil rate appear to form a cluster with 3 outliers: average downhole temperature and oil rate. Now, average wellhead temperature and water rate appear to form a cluster with 1 outlier. So all those outliers, all these are just ways to identify outliers and to deal with them. All those outliers are irregularities, right? So you know what to do with them. Oil production accounts for majority of the upstream hours, which makes sense. Average wellhead pressure shows a repeating pattern. Again, things that show repeating pattern like this are most likely most likely time series parameters that just change with time. So you see average wellhead pressure. It may depend on a number of things, maybe the choke size and all that, but then it also depends on the downhole pressure as well, right? So the downhole pressure is not something that you can fix. It's not fixed, particularly for a well that is not a green field, that's not a new field. It's not fixed. It's going to be changing. So even if nothing is happening, just with time, it's going to keep. Today that's normal with production. Today is at 5,000. Tomorrow it's going to be at 4,000 something, and then it will go back again to around that, or maybe even more than that. So that is normal with production system. Those oscillations. Just no other thing. Just time. It's time that affects it. Just with time, they keep going up and down. So that's normal. So when this shows a repeating pattern, you try to find out what could be the reason. It could be that it is connected to another. It is related to, or it is influenced by another parameter that just depends on time, right? Then we have average downhole temperature and choke size appear highly correlated with two outliers. So we saw this before, but something similar to this before. You can see that they have consistently said, like twice now, they have said the choke size has a correlation. So take note of it. We are going somewhere with this particular one. The choke size appear to have a correlation with the average downhole temperature for that well. Now, oil rate and gas rate appear highly correlated, easy to understand. So you have highly correlated. So you have, when you have more oil production, you definitely have more gas production at the same time, right? So that's basically what is happening here. Oil and gas production at once. So when you have generally more production, you have both more oil and gas production. Then we have, that's for that particular well, I mean, right? So then we have a case of downhole temperature and choke size appear to form a cluster. Now, wellhead pressure and choke size appear highly correlated. Highly correlated, okay? So just in case the question you want to answer has something to do with the wellhead pressure or the choke size, you can see that there is a connection between them. Now, you know that by theoretically, wellhead pressure and choke wellhead pressure and choke size are related. So it's not just, like I said, sometimes some things might not follow what we know theoretically. Some fields or some special cases might not follow what you know theoretically, but that's what data is saying for that particular system. So some systems might not follow the laws you know or the physics you already know, right? So, but that is what the system is saying. That's what the this particular system, and based on the condition it was in as at when the system was operating. I'm saying a system because it doesn't have to just be only petroleum engineering. It can be basically any engineering system, right? So we have average downhole pressure and oil rate appear to form a cluster. Again, you keep seeing all this. Now, I want to go somewhere with, there's a particular one I'm looking for. So we have something like this, average wellhead pressure. This is the distribution, the histogram, right? Let me insert it here. So, although one thing with this chart, I'll show you how, maybe if there's sufficient time, we'll see how to use it, do a better histogram. So it just shows you ranges from 0 to 1500, from 15 to 30, 30 to 45. And so this is the histogram for the wellhead pressure. Now, look at this, I think this one for choke size, yeah, you almost have a bimodal system here, but this one is just too low. If not, I would have said you have a bimodal system. But in this case, you see that there's a valley here, and then there is at least a slight rising here as well, right? This is for the choke size. Now, look at this, the choke size. You have one point here, and then you have a set of points here. So what this could actually tell you is that, number one, there's a lot of data recorded during when the well was not producing, or that have zeros in the data. That's for the choke size. I have zeros as the choke size at the time, or the bin size at the time, right? So while others, there might be other values for the bin size, but they are concentrated this other side. So that is downhole pressure. Now, this is the water rate. Now, I want to say something here about this. When the histogram or the distribution of a plot appears to be either right skewed, left skewed, or you know, or normally distributed. Now, when you find out that you have a chart, a distribution like this for the oil rate or for any other, maybe the oil or the gas rates, what this is showing is that the values, most of the values produced, there are a lot of values, right? Most of the values of the production were concentrated around, were low, were concentrated around this point. Yeah. Most of the values from the production were concentrated around this point. Now, if you have a green field and the field keeps producing, the production rate keeps increasing steadily or from time to time. Of course, the way the whole thing is, you certainly have lows, lows, every day keeps oscillating, going up and coming down. But then when you plot the distribution for such a green field, you discover that it's most likely going to be left skewed, right? Left skewed. So the distribution if you plot the production rates, you are likely going to see a left skewed data. That already begin to suggest to you that this field is a green field. The pressure has not even stabilized, so the rate keeps increasing. So you have a left skewed data here. So, but this one will tell you that this data is kind of, this field is a brown, it's not just a brown field, but the oil production is depleting, or the water production is depleting, right? This right skewed one is telling you that the water production, because you're having much lesser values, higher values here, and more values, lower values here, right? Now, in this case, we have average wellhead temperature. So we have a bimodal distribution here, right? You have a bimodal distribution. What does this mean? Okay, like I tried to hint yesterday, this simply means that there are two factors or two conditions under which those values were measured, two different separate conditions that don't have any relationship with themselves, right? So what could those two different conditions be? In this case, you have a set of lower values here, and then you have a set of higher values here. When you have a temperature sensor on your well, it also measures ambient temperature. So it's not just zero when the well is not producing, right? It's not just zero when the well is not producing, right? So it measures the temperature of the well based on the ambient temperature, the wellhead. So that means that when the well is producing, there is a certain temperature. It could be any value, but it's definitely not very low, it's at least high. But it could be any range of values, but at least it's high, right? But then when the well is not producing, those sensors are still measuring temperature, and then it could be any values. It doesn't have to be one particular value. It could be a range of values. But then you can see that there are two different conditions. You can classify the two conditions. You can classify the whole thing into two, when the well is producing and when the well is not producing. That's what I'm trying to say about the bimodal distribution. So it has classified you can see that there's a classification of the conditions into two, when it's producing and when it's not producing. So the data here, you see a bimodal distribution, right? Again, this is the frequency of the gas rates and the oil rates. It's just pointing to a declining production, right? Production is declining. All right. So there's a lot more information you can get that are not written here. These are just the suggested one. For example, you can type let's say we can't really do much here because there's just a single well. So the questions I would have loved us to ask. Okay, let's go back to the other data, and we'll use it to. So when using the other data, we'll not use anything that has to do with the dates, right? Because the date is kind of it's having a lot of issues, right? So let's keep going. Let's go back to the other data. All right, here we go. So this date is problematic. It's kind of, it wasn't what I expected it to be, and this wasn't exactly the data I had in mind. I somehow must have carried the wrong one somewhere. All right, so I'm going to work with this part of. Let me delete this. I'm going to delete this column. But generally, this is how you do it when you have that kind of problem. It's only that this one was more sophisticated, and I don't want us to waste time because I didn't plan that. So that's why I'm deleting this now. So, all right. So let's say we have something like this in this case. So I'll close that tab. Let's say we have something like this. In this case, remember we have different field names, and we have different reservoir names, and we have different well names. So this one will kind of be a little bit more exciting, right? So let's see what we can get there. Right. I just wait for this to load. It's a huge data set. So this one, I don't know how long, but let's hope it's fast enough. But even if it's not fast enough, we'll just switch over to, we'll just keep going. All right, good. So you can see that we have a pivot table here as one of the insights, but I will not, because we are going to treat this towards the end, I will not go into that one now, right? So, okay, just these two. How come? I think it's still loading or something. Okay, let me do this. Okay, in this case, you have field name Kwali and Owian have noticeably higher oil rate. So if I insert, this is a pivot chart. If I insert this chart, you will see that already you can see here that it's kind of classified in a bar chart, illustrated in a bar chart, all the fields and their oil rate contribution, all the various fields, because they're about different fields. There are about 7 fields here, right? So this is just one of the things you can. Now, if I wanted to search for a specific thing, I can say what's or which well has, I will have to specify which well. You have to specify the particular column because it has to be exact name, the way exactly the same way it's written here, right? Oil rates, change it to this, okay? Okay, so this is what we have here. It provided the answer and then provided some of the oil rates, but I want to put it in a bar chart. I'll say oil rates by well. Oil rates by well. Somehow it keeps bringing table. But what I want is a bar chart. All right, good. So this is what I have here. Let me insert it in, and it will come to open up a new page. There's a whole lot of wells, so you can't actually represent all the wells in the chart. So what I can do is maybe top 10. I can say top 10 oil. Good. So yes, so this is going to show us the wells with the highest oil rate, right? And you can see that it's one from the Ovwean field, right? According to the code name here. And so we have all this. So I could also say time series I'll say oil rates by dates. Okay, sorry, I'm not going to use dates. Or I can't use dates because of. All right. So, but basically, these are some of the exploration we're going to do, or you can do with with uh, these are some of the exploration you can do with the parameters here. So for this, we have sand by field name. So it's just going to show you the total sand production from each field. And then you can tell which field produces much more sand. You can also go by well if you want. So with all this information, with all this information, you can use them to either create a report, right? Or if you want to build a model, right? You can get the information you need to build the model. So those are two of the things you might want to do after getting answers you need from your exploratory data analysis, right? So instead of going through why you could do all this manually, like the charts we drew and all that, this is just a very simple way to do this in Excel. Yeah. So where it can be done, of course, this can't respond. What you just do is that you use your you manually try to do the charts, right? So I believe at least you have learned how to insert charts and all that. Now I'm going to go straight to what we call finding correlation between parameters. I'll go back to, okay, just in case the time is not enough, this is a similar this is a simple report. I'm going to continue from here, or just to show us how you can create a beautiful report in Excel, a dashboard report with a drop-down list and some other things. You can just help to make the whole thing dynamic and automated. Although I fear that time might not be on our side on that. But let's quickly go back to I'll delete all these charts now. Let's quickly go back to the data we have here. Now, I want to build a multivariate regression model, right? I want to build a multivariate regression model, and I want to use the parameters from here, that is these columns, which I will call features, right? So before I'll do that, I'll need to do what we call a correlation, either a correlation map or correlation table, right? So that I'll see how well each of these values correlates with my objective. What do I want to do? I want to try to develop a formula or a model I would use to predict, let me say I will use to predict oil rates, right? I'll use to predict oil rates. So we have oil rates, and then we'll have all these other parameters as the predictors, right? So you are developing a regression model. Again, we are developing a regression model to predict oil rates. So all we just need to do is to try to put in some parameters and see the value the model will return, and compare it to what the actual value was in reality for that well. And that is just what it is, right? So before we can build that model, we need to let's first of all fill in. It appears there are some blanks here and there. Let's try to fill them up so that. So I'm going to go to Find and Select, go to Spatial, and blanks. then replace, let's just fill them up with zeros, or if we want to delete them, we can. All right. So if you want to do data analysis in Excel, the very first, and if you want to do anything related to statistical analysis, the very first toolkit you must have in your Excel is what we call the data analysis tool pack, right? The data analysis tool pack. You use that tool to there are a lot of statistical and probability tools that you can use for whatever it is you are doing, right? So it's going to make your life easy. And that tool has been available in Excel for a while now, at least for several versions back. But just in case you have never seen it, you will find it in your data tab. You'll find it here in your data tab. Here is where you find it. And normally by default, it might not actually be here, right? So if just in case you check your Excel now and you don't find it there, there's no problem. There's no cause for alarm. How you can get it out here is by going to the File tab and going to Options, going to Add-ins. It's a follow-com add-in. It's not a third-party add-in. You can select Excel add-ins here and click on Go. Now, here you will see a number of add-ins that that will make your life easy in Excel. One of them is the Analysis Tool Pack, and then the other one is Solver and several other ones. But we are going to leave Solver for now, and we'll click on the Analysis Tool Pack. Now, if you discover that it's already checked here in yours, and yet you can't find it here, what you do is that you uncheck it, click OK, then go over the process again and check it. Like that, it will show, it's going to show up. So I already have it, click OK, and we have the data analysis tool pack. So I want, remember, before we even start talking about data analysis, the oil rate is the column I want to predict. It's a target variable. So I'm going to move it. Let me move it to. Okay, before that, I think I should create a column here. Let me create a column here. All right. All right, so I just want to keep it at the leftmost of all the numerical columns I'll be using, right? So it's going to be at the leftmost end, yeah, and then I can just delete this, this one. All right, so going forward, we would have the data analysis tool pack. Sorry. Now, in the data analysis tool pack, when you click on it, you will notice there is a dialog that has a lot of statistical modeling tools, right? You have things like Fourier analysis, correlation, covariance, and moving average. Then you have things like sampling, you have regression. I regret there's not enough time for this. I wanted to at least do the what we call the Z-test, where I would have to do what we use it for normalization, what we call normalization. Yeah, we talked about normalization, Z-score normalization, right? But we won't be able to do that based on time now, right? So let's quickly see how we are talking about correlation. And what I said is the particular kind of correlation this tool uses is the Pearson's correlation. So I'll click on OK, and it will bring up this dialog, this other dialog box. And all I just need to do here is first to input the range. So I will input the range of all the columns I want to find their correlation. So basically all the columns here, and I'll click OK. Now labels in first row. That's correct, because the label, the column names are the labels, and yeah, the first row. So then the output option, I want it to be on a new worksheet that should be opened. So I'll click on OK. Now there's a problem. It says the input range contains non-numeric data, and that's possibly because of this column. Sorry. So you will notice that it's kind of, you need to delete this column. It's not numeric, so it has, this one also has no data, so I think it should just be deleted. All right, so let's go back to what we wanted to do. All right, so this is no longer E to Q again, this will be E to O, because we don't want to include those non-numeric columns there. So we'll click OK. Now pay attention, guys. You can see something here, right? You can see there's a new sheet opened, and you have this. I'm going to let me increase it and bolden it so that we can see it, can all see it clearly. All right, let me also increase the. All right, so this is like a grid, a table, having correlation of all the those variables, right? So we have all those labels or or predictors, basically all the variables we had in our table, right? From oil rate, on stream hours, the average downhole pressure, temperature, and then you see the same parameters written here. And then you also notice this one along the diagonal, which shows that the points where they correlate with themselves. So a parameter the correlation of a parameter with itself will be perfect, right? Perfectly one, right? So, but then the other things you want to quickly notice is the other things you see there are values, the correlation values, the Pearson correlation values of each of these parameters with themselves, right? So with other parameters. So for on stream hours with the oil rate, this is 0.76, which is a high correlation. Somehow the on-stream hour seems to have a high correlation with a high positive correlation with the oil rate. The downhole pressure rather seems to have a negative correlation with the oil rate, and it's not so high. Now you'll see also negative values, and you'll see these errors here. Now these errors are for columns that are having zeros, or yeah, they have zeros in them, or probably they are completely empty, right? Because if you remember the Pearson formula, it has to do with division, and you know, when you are trying to divide with zero, you get this division, this error. Now, what we are going to do next is that we're going to redo this correlation, but we are going to remove, and you notice that it's with this average annular pressure, the same thing from this end. Those are the only errors we have from the average annular pressure. So let's redo this correlation, but this time, let's delete that column because clearly we don't need that column, right? Average annular, let's look at the column first. Now you'll notice that it's almost all zeros, right? And blanks. So you can see that we have just zeros and blanks here, right? So let's get rid of this column. All right. So let's redo. First of all, let's delete this. Sorry. Let's delete this one and redo the correlation. Run the correlation again. So it's no longer going to be E to O now. It's going to be E to N. So column N, right? Because that's where the numerical values column stops. All right. All right. So I'm going to now highlight this, then extend it a bit. I'm going to do this for here as well. Oh, that's too large. All right. So going forward, this is what we have as, you see that we no longer have those errors here. Now, correlation could be positive, could be negative. So don't be scared with these negative values. Of course, correlation could be negative or positive. But what you should be concerned about should be the magnitude, right? So when correlation is too very low, it just shows that when it's very, when I say low, I mean not in terms of, okay, let me put it this way. When the closer it is to zero, right? So because even if it's negative, and it's like minus 0.9, that is a high negative correlation. It's a high correlation, even though it's negative. But the closer it is to zero, the smaller and weaker the correlation, right? So what that simply just means is that there is a very weak relationship between those two those two parameters. In this particular case, the target variable is the oil rate, and you can see that there is you can see that some of the lowest correlating variables are average wellhead pressure, DP choke size, and downhole temperature. They are the lowest here, right? Then the highest on stream hours, you have average choke size, you have wellhead temperature. Now, look at this. You have gas rates. Now, do you know why gas rate is very high? The reason is because there is a concept in data analytics we call data leakage. Data leakage. Yeah? Why do we call it data leakage? So let's assume you are playing you are trying to predict a match, right? Let's say two teams are playing, Brazil and Portugal, or France and Argentina. Let's say France and Argentina are playing. And the match is tomorrow. And your model, you are supposed to predict the scores today, or at least before the match. But when do you start? But some persons, but you actually wait until the match has already begun, and the goals have already been scored, and then that's when you start predicting. So in that particular case, you're already cheating because you have seen into the system already. You have seen into it already. That's the same. That's the concept of data leakage. Gas is produced alongside oil, and it will normally correlate with oil. And the oil, if the oil have already been produced, what then are we predicting? You get the point now. If the oil has already been produced, because we produce the oil alongside the gas. So if we have the oil already, so it is more like an expo. It's cheating. It's already spying into the system. So it's already giving you clue. It's giving the model undue advantage, right? So that is it's going to give the model undue advantage. So this kind of case, it will make sense if we remove this column, the gas rates, right? So because it's going to cause data leakage. Then we also have the same, I think the same thing with the water rate. But then for some reasons, I will leave it. Now, there's a concept I want to, apart from this 0.99, you'll notice that there are other 0.9 here. It's not just this one. Okay, let's use, to visualize them, let's use conditional formatting so that you can see any cell that is above 0.9. Okay, let's say 0.8, right? To be highlighted with red. All the ones, of course, they are above, they're highlighted. But then you can see other ones here. You can see the average wellhead temperature with the on-stream hours correlating, very high correlation. You can see the choke size with the on-stream hours, very high correlation. Same thing with the average wellhead and the choke size here, and the average wellhead pressure, and also this other choke size. There are two different choke sizes in the data. So you see that as good as this sounds, correlating with themselves, if you try to use two models that have such a very high correlation to build, two parameters or two predictors that have very high correlation to build a model, you have a problem. Yes? What is that problem called? In a case where you have two different parameters, two different variables, and both of them are kind of they look very much alike, they have very strong correlation, the model can approximately see them as the same, right? The model can approximately see them as the same. So they are going to confuse the model, because the model needs to know specifically which of these two variables, particularly when it comes to the side of trying to interpret what we call interpretability. Interpretability simply means which biases and which weights will I give to this variable, right? And which weight will I give to this other predictor variable, or which importance will I assign to this other part. So when the model tries to do that distinction, it's going to be a bit difficult, because it's not going to be able to tell the difference between the two models, right? So they have similar importance, right? Then again, the model two will have this problem of not being. Sometimes it doesn't happen in all cases, but in some cases I've noticed myself, the model would have a problem of not being accurate, right? And that's some of the things you want to note. So when you are working with trying to do a prediction, we are trying to do a predictive model, you come across this case where you have two variables highly correlating with themselves, right? It will make sense if you can remove one of the variables, right, and use only one. Hello guys, sorry, a minute. All right, so I was just talking about I'm back. I was just talking about the predictors. In the case where you have two variables, in the case where you have two variables that are collinear, like they are highly correlated, so you would have in data analytics, it is called the course of multicollinearity. Right now, it's called the course of multicollinearity here. So what that simply means is that those two would actually lead to a problem later on. They will not give you the accurate interpretation of the weights and biases. So the model you will get will not predict well, right? Our time is really fast spent. We still have a few minutes to. But let's quickly see how to build our multivariate model. Now, I'm not going to be able to do much in terms of trying to pick up or remove these models. So I'm going to maybe leave it for you as an assignment, because I want to hurry up from here now. I'll go back and see how to improve this model we're going to build now. By number one, these are several ways you can improve the model. Number one, you have to do normalization of the values, because if you notice, these values here of different scale. So the more if you can make all these values to put them in the same scale, the model will be more accurate, will be more effective, Number two, remove these parameters that have problems with multicollinearity. In fact, let me just leave them here and I'll show you, let's build the model, I'll show you what it will help to, it's going to help to drive the points faster. Now, let's go back to building the regression model. From the data analysis 2 pack, we have the regression tool here. You can find it here. I'll click on OK. Now, on this dialog box that open, there are 2 input ranges or cells for input. The first one will take the Y range, that is the target variable. That variable in our case will be the oil rate because that's what we want to predict. So remember what we are doing is we are trying to train a model. We'll use the labels or the targets, right? And then we'll use the other variables, the other predictors. We'll try to, what happens inside there is that it tries to formulate a pattern by continuously comparing. It will form a pattern with the predictors and then compare it with the outputs. If it's not okay, it forms another, it keeps updating it. It keeps updating the weights and biases until that model, it produces the best it can. Try to model the relationship between between them, right? Now, in this case, I'm going to select the oil rates, right? I could have stopped somewhere around 733. Yeah, okay, so that I don't model these zeros. It simply means there was no production. Let me say 730. Let's just stop at 730. Then I would put in every other cell into the model, every other predictor, apart from the oil rates. Okay, no, let's see. No. So I'll put here 730. All right. And then we have labels. That means we highlighted the column names. So we'll click on labels. And then some other option you might want to look at could be, you might want to select could be the some of these functions here. But I think one that is very important is the residuals. That's this one here, because we need the residuals to to check our model rather. Maybe if we have time enough, we'll look at the residual plots and the line fit plots. But it's going to be so many for each of them. It's going to be so many because every plot there'll be a plot for each variable, each column, right? Those plots just show us how well they compare with, how well they predict the how strong or how well those models, those variables perform in the model itself. So I'll click on OK. There's also probability plots too. We'll come to that, but now in this case, this will open in a new worksheet, and let's run this. Okay, so we already have the model here, and I'll highlight this. Okay, good. I'll probably just highlight this a bit. All right. So let me further highlight this. Okay. So this is what we have. This is what we have. Now, this is the model, but then being able to just do this, clicking a few buttons here and there, it's not what the model is. It's not really what shows that you can do modeling, right? It's a little bit more complicated than that, right? So let's begin to look at what was the output from the model here. We have these parameters. Okay, they were in my slide. The multiple arrow, the R square, which is called the coefficient of determination. It shows you how accurate your model is. And then the adjusted arrow square, the standard error, the number of observations. So the number of rows in the data was 728, or the number of samples or that was used is 728 rows, right? Now this actually shows you how accurate your model is. In this case, it's telling me 99.2%, which is actually looking so sweet and nice. But then let's look into this. This is not the only thing we use to judge our model, right? We use a lot of other things. Now, there's what we call the sum of squares error. Okay, first of all, there's what we call the degree of freedom, right? The degree of freedom. Then there's what we call the sum of squares error, this one, sum of squares regression, and sum of square errors, right? Or residual, the SSR or SSE, same thing. Then we have the mean square regression and the mean square error, right? Then we have what we call the F factor, right? Now, the significance F. Now, this value here showing 0 is pointing to something. It's pointing to how well, how well the variables, the predictors together, they are significant to predicting the model, and it's showing 0. That's a problem. Now, let's come down here. These are the intercepts. Oh, hold on. Sorry, there's something wrong. I think there's a mistake. So this is supposed to show the column names. This is the intercept, the first one, which is actually the bias. That's the constant, the one we have as a constant. If you remember in our slide, when we talk about
Sincere apologies for the break in transmission. The lecturer will join shortly. So sorry about that. Once again, very good evening, everybody. We really apologize for the network challenge our speaker is having, and he has advised that instead of making you burn your data, we continue this and probably share a YouTube link where you can watch the remaining part of this training. Thank you so much for being part of this lecture for the past 2 days, and I believe we have learned so much. So kindly follow and search our YouTube page, SP Abuja section on YouTube. You'll see yesterday's lecture, you'll see today's lecture, and you also see the continuation of today's lecture, which will be uploaded later when he regains good network. Thank you, and thank you. I'm going to post the YouTube link in the chat box so that you can check the YouTube link, and then our previous sessions, trainings, webinars, you can navigate the YouTube page and watch whichever you like. Thank you, and thank you once again.